Explanation on memory cache techniques, direct mapping, that is fully associative mapping, and set associative mapping. So we begin with the memory cache techniques. So memory cache is a small, fast memory located close to the CPU that stores frequent access data from the main memory. Caching improves performance by reducing the average time to access data. It has several techniques used in manage and access cache memory efficiently. So basically, memory cache is a small portion of memory that is much closer to the CPU. Sometimes it is embedded on top of the CPU. So it stores temporal or frequent requested memory from the RAM. Instead of the CPU traveling all the way back to access data from the RAM, it's actually looked through the cache, and if that data that is looking for is located in the cache, it will just draw that data from there and process it, which makes it much more faster rather than going to the RAM to access it. So we have a write through versus write back types. So the write through, the data is written on both the cache and the main memory simultaneously. It ensures data consistency but is slower. Write back, data is written in the cache only and updated in the main memory only when the cache book is replaced. Faster but may cause data inconsistency if not properly managed. So with the write through, both the data are written both on the cache and the main memory, which is much slower because once it's written on the cache memory, it has to go back to the main memory to write this data. And the write back will just replace information on the cache alone without getting closer to the main memory. Sometimes some of this causes inconsistency and not properly managed because once the cache memory is full, once it's about written, it will delete the oldest or the ones that is not frequently used and use it to store the new data that is about to write on the cache. So cache replacement policies. When a cache is full, a new block needs to be loaded. One must be replaced. Common policies include least recent use, replaces the block that hasn't been used for a longest time. So normally when the cache memory is quite much smaller than the main memory or the RAM. So when it's full and data needs and it's full but data need to be written on it, it actually go to the least recent use, the one that's not be frequently used, and it replaces that data with a new one. First in, first out, replaces the oldest block in the cache memory. Random replacement. So this one, it replaces it randomly. It selects a block randomly, whether it's recently used or last recently used. It will just replace it. So let's get to fetching. Anticipate the data the CPU will need and loads it into the cache in advance to reduce latency. So normally the cache works enhanced with the RAM. So when the cache can anticipate that once the CPU is processing this data, it will need this particular data or information, and quickly it will fetch that data from the RAM to the cache, so that in case the CPU needs it will not go back to the RAM, it will just take it from the cache. So it reduces latency. Cache write policies. Write allocates. Load data into cache on a write miss and then writes. No write allocates. Writes directly to main memory on a write miss without caching. Cache mapping techniques. So we are back to the point 2. We are coming to talk about the cache mapping techniques. So cache mapping defines how data from main memory is placed on the cache. There are 3 main types, that is direct mapping. Each block of the main memory maps to exactly one cache line. So we have blocks in the main memory and we have blocks in the cache line. So each line in the main memory is matched to the exact line in the cache memory too. So we have the advantages, that is simple and fast. Disadvantage: multiple blocks competing for the same cache line can lead to frequent replacement. So the cache line is quite small, as I told you earlier. Sorry about that. Fully associative mapping. Any block of main memory can be replaced in any cache line. Requires a full search of the cache to find a block. Advantages: very flexible, no conflict misses. Disadvantages: slower, more expensive due to complex hardware need. So we get to the set associative. That is a hybrid of 2 methods above. So the joint together of the two methods that I've already talked about. The cache is divided into several sets. That is two-way, four-set way associative. A memory block maps to a specific set but can only go into any line without that set. Example is a four-way set associative cache with 64 lines. There are 16 sets, each with 4 lines. Advantages: balances between speed and flexibility. Disadvantages: more complex than direct mapping. So the set mapping combines the set associative mapping combines both the fully associative and the direct mapping. All right, so we have the techniques, the flexibility, the speed, and the cost. So the direct mapping is quite low, but the speed is very fast, and the cost is low too. The fully associative flexibility is high, the speed is very low, and the cost is high. But with the set associative, it is medium. So ideally, it would best to go with the set associative mapping than the direct mapping of fully associative. Thank you.